All right, so this is day one. We're starting 3 chapters worth of trig. Trig is a basic foundational skill that you must have in any future math class. You will use this stuff over and over and over and over again. It's just like factoring, it's not going to go away. And oh, by the way, we had a factor in trig too. So, trig is used pretty much with anything that has curves or waves. So trig is used to understand everything from electrical current. My oldest brother is an electrical engineer, he uses it all the time, electrical currents, to modern telecommunications. So essentially anything with waves or curves. And we will be exploring sine, cosine, tangent, and their inverses, their graphs, and what they look like. So today we're just starting off basic. We are going to convert radians to degrees and degrees to radians, but first we need to know what a radian is. So this should start to sound familiar to you because you should have had this in Algebra 3-4. Should have. So, definition of a radian. 1 radian is the measure of a central angle that intercepts an arc S in length to the radius r of the circle. It sounds like a whole bunch of blah, 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 wah, 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 right? So here's what that is saying. 1 radian is equivalent to, do you see the central angle here, theta? Right there showing that central angle. Let's go in there closer. All of this is saying is the arc that central angle intersects, and you learned how to find the measure of that arc in geometry, so geometry is going to get pulled in here as well, needs to be the same length as the radius of that central angle. If the radius and the arc length are the same, that is equal to 1 radian. So we took a circle. Oh, and by the way, that's what this is saying here. S is equal to R. That's all you can take away from it. Definition of a radian is the arc length is equivalent to the radius of a central angle in a circle. All it's saying. So then look at the circle. This shows you how many radians are in 1 full circle. So 1 full circle, you have 6 full radians and then a little partial. So let's go and review a few things that you did learn from 3-4. So let's start at 0 degrees. Isn't that what 0 degrees is? And we go counterclockwise. So what's halfway? This is 180 degrees. Halfway around the circle. What's halfway to 180 degrees? So that one's 90 degrees. What's halfway? 270. So see, it's all coming back and all the way. So we hit that starting line twice. And then each of these has radian measures associated with those degrees. So the radian measure of 0 degrees is 0 radians. This is the distance of 1 full radian, and that's in terms of numbers. We'll get to that in a minute. That's a decimal, so let's see what we do. All radian measures typically, not always, but typically have a pi in it. So from here to here, 180 degrees is the same as pi. So half of a circle has a radian measure of pi. So a quarter of a circle has a radian measure of pi over 2. So if I take pi and add another half of pi, don't I have 3 pi over 2? And then if I take a pi and add another pi, don't I have 2 pi? So the degrees are in blue, the radian measure is in pink, and radian measure tends to be in pi. Now we could also view radian measure in terms of its decimal equivalency. And that's going to make a little bit more sense as you see the radian markings here. So the decimal equivalency for 0 is, again, 0. Decimal equivalency for pi is what? Out to 2 decimal places, 3.14. But what's half of 3.14? 1.57. So 1.57. So just look at this half a circle for right now. From here to here is 1 radian. And then from here to here is 2 radians. Isn't pi over 2 90 degrees? Isn't it a little over halfway between 1 radian and 2 radians? Does it make sense that at 90 degrees this would be 1.57 radians? Because it's just slightly over halfway. So these radians that you see here are the decimal equivalency of the pi version of the radians. And then here, this is 3 radians here plus a little smidgy to get to pi. Isn't pi 3.14? 0.14 is a little smidgy. It's a technical word. We'll go with it. And then that means that this decimal equivalency must be 4 point something, and shouldn't it be pretty close to 5? So add these two together, 3.14 and 1.57. What does that give you? 4.71. Isn't that close to 5? Yep. And then 2 pi. What's 2 times 3.14? 6.28. And isn't this a little bit more than 6 radians? So that's how all of that comes about. And you might see radians in terms of its decimal equivalency or in terms of pi. It just depends on how the question's asked. Okay? So sometimes radians doesn't have a pi attached to it. So let's do some conversions. So I have some lovely, beautiful pictures over here. We're going to convert specifically degrees to radians. Well, we like to use, let's backtrack a little bit and talk about conversions. If I were converting inches to feet, what is the conversion for inches to feet? Just as an example. There are 12 inches that equal 1 foot. Would you say that 12 inches is exactly equal to 1 foot? Well, we're going to use here that pi is exactly equal to 180 degrees. So pi radians is equal to 180 degrees. Pi radians is equal to 180 degrees. This is where we come up with our conversion from degrees to radians and radians to degrees. If I were to convert 8 inches into its portion of a foot, I would have 8 inches over 1. And then I have to decide, do I want to put 12 inches up top or 1 foot up top? Right? If I write 12 inches over 1 feet, would that get rid of my inches? If I had 8 inches. 8 inches times 12 inches over 1 foot, would that get rid of my inches? Yes or no? Yes. It would. 8 inches over 1 times 12 inches. Don't inches have to be diagonal to each other? So whatever you want to get rid of, so if I want to convert inches to feet, whatever I want at the end needs to be up top. So if I want to convert inches to feet, my 1 foot goes up top. And that way my inches are going to cancel out because they're diagonal to each other. And then of course I would reduce my 8, my 12, and then I would get my portion, my foot, right? Same thing's going to occur with pi radians and 180 degrees. Sometimes we're going to put pi radians up top and the degrees in the bottom, and sometimes we're going to reverse that. If I want to go from degrees to radians, don't I want radians up top? If I want to go from radians to degrees, then, and I'm going to degrees, then I want degrees up top. So here's just some typical conversions. So if I want to convert degrees to radians, we've got 30 degrees. All I have to do is multiply 30 degrees by pi rad over 180 degrees. Doesn't the 30 divide into 180 how many times? 6. The pi doesn't divide out, so we get pi over 6. 45. I would have 45 over 1 here. The 45 is going to go into 180 degrees. How many times? 45 and 45 is 90. So wouldn't it be 4 times? So we end up with pi over 4. And the same thing here. Now the reverse is true. If I have 90 degrees versus pi over 2, well, if I'm converting radians to degrees, which of these two is radians? The pi over 2 or the 90 degrees? 90. Which is radians. Radians always has pi in it. So like this one, I would be multiplying by pi over 2. I want to go from radians to degrees, so notice my degrees are up top. Don't my pi's cancel out? Right? And doesn't 2 go into, and by the way, this is a radians up here. I'm not used to having radians in my question, but for right now, they're going to put radians in that. Doesn't 2 go to 180, 90 times? So that's all they're doing. So we're going to do the same thing down here in example 1. So we're going to convert. We don't need a calculator to do the conversion. So I'm going to start with my 135 degrees. I'm going to put it over 1. And I have to decide, do I want to have pi rad over 180, or do I want 180 over pi rad? Since I'm converting from degree to radians, what do I want up top? Pi rad, because I want my radians. So I'm going to put pi rad up top, my 180 degrees in the bottom. Now I know your degrees looks like an exponent, but it's really a unit of measure. Technically your degrees cancel out. And then if I use proper canceling skills, what goes into 135 and 180? What do they have in common? 5. I know that they have 5 in common. It might be more, but most people off the top of their head are going to go 5. Right? So how many times does 5 go into 135? 5 goes into 13 twice with 3 left over, and 5 goes into 35 7 times. How many times does 5 go into 180? 5 goes into 18 how many times? 3 times with 3 left over, and 5 goes into 30? 6 times. So what divides into 27 and 36? What do they have in common? They have a 9 in common, right? 9 goes in here 3 times, and 9 goes in here 4 times. How did that not work out? Oh, 9 goes in here 3 times. What the heck? I said it and wrote it wrong. All right, so our final is 3 times pi times rad. 3 pi rad over 4. Now, Math Excel is going to want just 3 pi over 4. I doubt they're going to want rad in there. And anything that has a pi in it usually is already in radian measure. I say usually because sometimes if pi is in the denominator, it can be a degree measure. But if pi is in the numerator, it's always a degree measure, or a radian measure. So then you do 270 by yourself. That one's a little easier with reducing. You do 270, and it's negative. The negative doesn't change anything. So share your answer with those around you. What do we get? Now, if you already recognize that, oh, remember, 270 degrees is on my unit circle, and 270 degrees is 3 pi over 2, then it stands to reason that negative 3 pi over 2 would also be negative 270 degrees. And so that stuff will start to come to you. Well, for this section, yes, but after this section, you're going to start to drop it. And you'll see me forget it all the time, so I'm just not using it. Yes, you actually can now. Now we can, and you'll see when we can. Yeah, we didn't used to be, but if we go backwards on the unit circle, we get a negative degree. But a good question. Why are we using this one? We're always using this as our conversion for radians to degrees because we know that one or a pi rad is exactly equivalent to 180 degrees. We could have used, and technically we could use 90 degrees equals pi over 2, but that's just not as pretty. Does that make sense? All right, so then we're going to convert in the opposite direction. Now you're given rads, and typically you're not going to see that word rad. They're just going to write the negative pi over 2, so if pi is in the numerator, it's assumed that it's in radian measure. This one, If you just see the 2 with no degree marking, so it's really important that we pay attention whether there's a degree or not there. It's assumed it's also a radian measure. So if there's not a degree with it, you can have a radian measure that doesn't have pi in it, as we noted up here, because here's 2 radians. All right, so let's look at the first one. So we've got negative pi, the rad goes in the numerator, over 2. I'm going to multiply that. We're going 2 degrees. So do I want pi rad up top or 180 degrees up top? Yep, I want the 180 degrees up top and the pi rad on the bottom. That way my rads cancel and don't my pi's cancel. And the 2 easily cancels into 180 degrees, 90 degrees. But we have this negative still, correct? So isn't our final answer negative 90 degrees? And again, pi over 2 is 90 degrees, but it's negative, so we're going in the reverse, negative 90. Let's look at the 2 rad, because it's kind of odd and weird. So we're going to start with 2 rad over 1. Because I want degrees, I'm going to put 180 degrees up top over the pi rad. Now, if you were doing the non-calculator portion of your test, this is what your answer would look like. Our rads cancel. The pi actually doesn't cancel with anything this time. And the 2 doesn't cancel. What's 2 times 180? So we've got 360 degrees over just pi. That's actually a degree measure, which is approximately equal to, if you were on the calculator portion of your test, then we would exchange. We would take our 360 and divide it by second pi. Don't use 3.14 because that's a rounding in the middle of a calculation kind of thing. And then round that to 2 decimal places. What do you get? 114.59 degrees. You would not, so what would happen if I divided it by 3.14? Oh, goodness. Hang on, let me put that one back up there. So there's our original, right? So if we divide it by 3.14, see how we're off? Instead of 0.59, I had 0.64. You need to put 0.65. So don't round the middle of your calculation, because I'm going to go, where'd you get that? Now, if the directions say to use 3.14, then of course do that. But if they don't say anything, it's always assumed to use the whole pi. Now, 114 degrees, isn't that bigger than 90? So from here to here, from 0 to here, does not look like it could be 114 degrees. That's the angle measure that we just found for 2 radians. So questions about that? Is that starting to ring a bell? I know you did that. Okay, then we're going to get more precise. We can actually exchange degrees into degrees, minutes, and seconds. And when we look at things written in degrees, minutes, and seconds, it's used mainly in navigation. And you might hear it called course. What's your course? Or bearing. Sailors, pilots, all use degrees, minutes, and seconds to narrow down their course or their bearing. And it's all based on latitude and longitude. Sounds like it's going to be related to our time clock, which it kind of is, but not really. So you need some conversions here. This is read 40 degrees, 20 minutes, 30 seconds. So this single here is minutes, and this double is seconds. So here's some conversions that you're going to need to be aware of. Each of these minutes, there's 60 minutes that make up 1 degree. So that means that 1 minute is equal to 1/60th of a degree. So that's a conversion factor that you might have to use. Then there are 60 seconds in every minute. So that means that 1 second is exactly equal to 1/60th of a minute. So there's a conversion. Or we could convert seconds to degrees. So if there are 60 seconds in a minute and there are 60 minutes in a degree, how many seconds are in 60 minutes? 3,600, so it's 60 times 60. So that's why we have this 3,600. So 1 second is also equivalent to 1/3600th of a degree. And notice that this one, because I have 2 of them for the second, this one is 1/3600th of a degree, whereas this one is 1/60th of a minute. So it depends on what we're trying to do with it. Just like we can have 12 inches equals a foot, or 36 inches equals what? A yard. Okay, so flip that. It's fun to do this on your calculator, not quite so fun to do it by hand. So you have to know how to do it both ways, just to let you know. So let's go ahead and look at our calculator. I've put here all the directions for you to use your calculator, especially if you don't have it here with you today. So if you don't have it with you today, you need to be even more diligent in looking to see what I'm doing. So the first thing you're going to do is put the 40 degrees in. And we have to put degrees. So look at your menus down here. We've got this menu called angle menu, which is above the apps menu. So we're going to hit our second function to get to the angle menu. And on that angle menu, there are degrees. That little single tick there is minutes. Oddly enough, seconds isn't in there. The other thing we're going to use is this degrees, minutes, seconds conversion, but we're not going to do it right now. Because we have something that's already in degrees, seconds, and minutes. Yes. Pardon? What button? Oh, that's under, it's above the apps. So you have to do second apps to get to the angle menu. And that's listed on your paper there. You're going to select number 1, which you can just hit enter, and that puts degrees on your 40 degrees. Then press 20, and then you want minutes, so go back to your angle menu, so second apps, and this time select 2, or scroll down to 2. But we also have to put minutes in. So oddly enough, and I was not in charge of the TI calculator, they threw minutes in all the way down here above your plus button. And notice that it's in green, not blue. That means you have to use the alpha key to get to that green. So we're going to press our alpha and plus to get to our minutes. And then if you hit enter, they may not get that on their calculator. Okay, because you're going to reach a point today that you won't get something, and we'll explore why that is. So this answer is 40.3375 degrees. So that's on the calculator. Now, how do we do that by hand? Well, we're going to use our conversions. So if you just look at what we just did here, the 40 degrees became the whole number part of our degrees here, correct? So we're going to do the same thing here. I'm going to take my 27 degrees, and I'm going to add to that my 15 minutes. I want to convert minutes to degrees. How many minutes are in a degree? Okay, so if I put the 15 minutes over 60 degrees, won't that give me the portion, because 60 degrees is equivalent to 1 degree. 60 minutes is equal to 1 degree. So that's my minutes and my minutes. So that's going to be my conversion to what portion of a degree is that. And we'll deal with that in a minute. Plus, well, technically I'm not, okay, if you want to be real technical, you could do it this way. So we've got 15 minutes, right, over 1 times, what's our conversion for minutes and degrees? Minutes is 1, what, 60th. So you'd multiply this by 1/60th of a degree. It looks like the degrees is like in the denominator, right? Technically it's really not. It's 1/60th of a degree is how that conversion is working. So I really don't have, I mean, consider it this way. If I were converting, go back to our 8 inches, If I were converting 8 inches into 1 foot, what would I end up doing? 8 inches over 12 inches, wouldn't that give me my portion out of my inches? So when I have 15 minutes over 60 minutes, it's essentially doing the same thing here. My inches are going to cancel out, and I have 4 goes into both of those, 2, and then 3 times. So I've got 2/3 of a foot. It becomes a foot. So it's not quite the same conversion as we were doing with the pi rads over 180, if that makes sense. So then look at our seconds. We are converting seconds to what? A degree, not a minute. We're converting seconds to a degree. So I have 25 seconds. How many seconds are in 1 degree? 3,600. That's the one that's not quite so common. So this equals 27 degrees plus, how many times is 15 going to 60? 4. So we really get 1/4, and now it's a degree, 1/4 of a degree. Plus, now we have to divide 25 into 3,600. You can do that little bitty bit of long division. It actually goes in there evenly, and I'm going to help you out of it. It's 144. Oops, the degrees actually goes up there. So it's 1/44 of a degree. Second should be small. Now, you're like, oh, how do I get that into a decimal? Well, I know what the 1/4 is as a decimal, don't you? So 27 plus this 1/4 is 0.25 plus. This is the only part that we have to do long division on. So I'm going to zip out here. So let's do a little bit of long division. Ugly but true. So 1 is up top, so 1.0000 divided by 144. Bring the decimal point up. Does 144 go into 100? No. It goes in there 0 times. But 144 goes to 1,000 at most. How many times do you think? 8? 8's too much. 7's too much. It does go into 6 times. And if I multiply 6 through to 144, I get 884. 144 times 6. Didn't believe me. 864. Oh, is that? Oh, that's because I can't read. 864. That's pretty funny. That's because I wrote it really small. All right, so then I'm going to draw my line, change my sign. I'm subtracting, right? What do I get? You have to convert 100 into 99. Put a 1 there. So don't I get a 6, a 3, and a 1? 136, bring down to 0. Well, it's going to go in there more than 6 times. So just to save time, I'm going to give you the rest of it. The rest of it is 94. And then 4 keeps repeating. So we've got 0.0069, and we're only going to go out to 4. But you could accomplish that by doing your long division. Then finally, our final answer. These are easy to add together. My 25 goes in place of the double zeros. So I have 27.25694 degrees. So the only really ugly part is that long division at the end of the seconds. Now, let's put that in our calculator and see if we get that answer. So I'm going to put in my 27 degrees, so 27 second apps, choose degrees, and then 15 second apps, choose minutes, and then 25 alpha plus gives me my seconds, and then hit enter. Is that what we got? Yippity skippity. All right, so then last thing that we're going to do is convert. Here we were converting to the decimal. Here we're going to convert to the degree minute seconds. So our calculator is quite simple. here's your directions for your calculator. You're going to put the 310.75 in. You have to put it in as degrees. We got 310.75. I have to select degrees, so go to second apps and select degrees. Then you can't just hit enter because it's not going to give you anything. You have to go back to your second apps, and this time we want to take, this is saying take the previous answer and convert it to degrees, minutes, and seconds. And so if I hit 4 and then enter, now it gives me my degrees, minutes, and seconds. And so I get 310 degrees, which makes sense because our whole number is 310. And then I get 45 minutes and 0 seconds. Ah, yours didn't come out like that. Here's why. That's correct. So if yours didn't come out like that, so like Brendan's looks like this, that's weird. Then go look at your mode. So here's your mode here. Click on mode. Notice that his mode says radian and not degree, and my mode says degrees. So now starting with trig, you have to start to pay attention to your calculator. When you put degrees into the calculator, you need to have your mode in degrees. If I'm putting radians into the calculator, then you need to have your mode in radians. And so now if he changes his mode to degrees, and then does the whole thing all over again, 310.75 seconds, apps, degrees, second apps, degrees, minutes, seconds, and now it hits enter. Now doesn't he get the same thing? So write yourself a big note. Seth, no? Are you okay? So write yourself a big note. Make sure your calculator mode is in degrees.
And how did you do that again, sorry?
I went to mode, and I just make sure that my degree is highlighted.
Okay.
Let's see what you typed in. That was in there. That is weird. Let's see what happens when you put it in degrees. Maybe because yours is a little high. Oh, you know why? You didn't put it in degrees. Isn't that weird? That's why, because you didn't choose degrees over there. That's interesting. It was viewing it as radians, and it still converted it. So yeah, it's because you didn't put degrees. One wrong made it right. Or two wrongs made it right. All right, so let's do it without a calculator. Are you ready? This is not so bad as the last one. So don't we know, just based upon what we did above here, that the whole number part is going to be our whole number degrees. So I know that I have, go listen. First and foremost, step 1, I have 37 degrees as my whole number. Ladies, you should be writing, not talking. This is how we miss things. Then for step 2, I need to take this decimal part of my degree. So I have less than 1 degree here, and I convert that into minutes and seconds. So the second part, part 2, we're going to take our 0.4, so 0.425, and I want to multiply that portion to my minutes. So how many minutes are in 1 degree? Because I want to know what portion of a whole degree in minutes is that. 60. So I'm going to multiply that by 60, and then that's in minutes, and that's going to give me my portion that is of 1 minute. So you can multiply that out. We're going to use our calculator just for speed's sake today. 0.425 times 60. We get 25.5. We don't want a decimal, but we're going to go ahead and keep that for right now. So I get equals 25.5, and that's in minutes. Well, I don't want the decimal portion of it. I only want the 25 portion of it. So now we're going to take the 0.5 of a minute, and so step 3, and take that 0.5 of a minute, and I want to multiply it and convert it to how many seconds that is. So how many seconds are in a minute? There are 60 seconds in 1 minute. And so that one we can do without a calculator. Isn't that 30 seconds? So then our final thing is to put it all together, because I want to finish off without, I mean, I could end up with a decimal here in seconds. It is possible. But it didn't happen here. So I've got 37 degrees. Forgot what I was doing there for a moment. And then I have 25 minutes, and then I have 30 seconds. That's my final answer. And that was all done by hand if I had actually multiplied that out correctly. So now, don't be packing up. Let's do that in our calculator and see if we get the same answer. So again, making sure your calculator mode is in degrees, I'm going to put in the 37.425. You've got to change it to degrees. So hit second abs degrees. Why are we still packing up? Oh, I know where you are. You can pack up. And then I got to convert that to its decimal or its degrees, minutes, seconds equivalency. So 4 and hit enter. Did we do it correctly? Yes, indeed. All right, so that concludes. So you're going to do the first, I believe it's the first 10 problems tonight out of the 20. There could be 11. You could look at the 11th problem. Because you want to get those out of the way before we do the word problems tomorrow.
Great.